Hey guys, this is Crystal with Open to Public HVAC School, and today we're going to be talking about wiring for your blower motors, whether you have an air handler with electric heat or a furnace for gas heat. And we're going to get into whether you can use a 3-speed for a 4-speed, or if you've got one of those old school 2-speeds. We're going to talk about how to change up your wiring and how all of this functions. So let's get to it. So here we have a basic wiring diagram of a 3-speed. Now this can apply to a 4-speed as well, because all that means is we're just going to have one extra speed to play with, usually a medium high, medium low. For 2-speed motors, what most people don't know is you're supposed to swap those from your heat to your cool depending on which speed you're going to use, say high speed in the summer and low speed in the winter. But most people don't do that. They just keep it wired up the same way. So what does all of this mean? Well, whether you have a 200, I have my pen all right here, 240 volt motor or a 115, 120, whatever you want to call it, volt motor. They both need to have a common, in which it's hard to see here because most common wires are white. So here's my poorly drawn line here, or common, if you will, and here's our speeds. So on most blower motors, well, I guess most of the more common ones I'm used to seeing, they have black for high, blue for medium, red for low. These are just your different speeds. If you have a gas heater, a furnace, usually one of these speeds are going to be on your heat, on your control board, and one will be on your cool. So this is what is going to change how fast the motor is going to go. And so when you have a electric heating, these are usually either connected to a fan relay or a fan relay board, something like that. And they're going to be on different sections on that as well, which will be labeled heat and cool, fan on, etc. This just means it's a ground, so the motor doesn't short in case there's a surge, something like that. This is going to ground the motor, so it's good to go. And these two are going to go to your capacitor, and all this is it's a line through, just like on our condenser capacitors. It's going to send a quick burst or charge, and then it's going to start up the motor because our start winding is going to be here. So on common, on 120 volt gas heating, that's going to be on a neutral line on your board because of how units sometimes aren't properly grounded. It's basically like a secondary ground, kind of. It's a little different. That has to be on the common, even though it says line. So if you're looking at your motor here, and even though it says our white is line, and then one of these speeds will be your other line, or 120, 120 if you're looking at a 240 volt motor. Even on a 240 volt motor, we cannot put two speeds together. And here's why. Your common doesn't run on the same leg of power that your speeds do. So essentially what you're doing is if you put two of your speeds together, instead of using your common wire, it's going to burn the windings and short the motor. Kaboom! So because these are all really, really close together on the windings, they can't be run together for power. this is going to be coming in from the opposite side. So even though this motor is running off of 240 volts, you absolutely have to have a common wire, even on a 240. So just to kind of explain that, again, on your gas, your common is your neutral, and then your lines are your 120. So a common question I get asked in the store is occasionally someone will have a 4-speed motor, and unfortunately, if we have something here that has had 3-speed motor instead of a 4-speed, can you use a motor that had 4 speeds and switch it over to a 3-speed motor? And the answer is yes, absolutely you can. And so what you're going to be paying attention to with that is 1, the age of the motor that you're replacing, and 2, that of course all the other specs line up. Make sure it's a 1/2 horsepower motor, match it up with that. Make sure, yes, your blower motors both are the same voltage. And this goes the same for whether you're buying this on Amazon, anything like that. Really need to make sure that every single one of these specs are matched. So just like we were talking about with the condenser motors, need to make sure that that horsepower matches. Need to make sure that the RPM matches. Make sure that the capacitors match. So even if you think, oh yeah, I've got a higher capacitor, instead of having, say, a 7.5, you've got a 10 that you were using on your old motor. Does that work? No, it does not. They have to be the exact capacitance. So if you get a new motor that takes a 10, and your old one had a 7.5, you absolutely need to get a new capacitor for that. Now, getting back to the speeds. So not only can you use a 4-speed for a 3-speed, you can also use a 3-speed if you had a 4-speed. You can also use a 4 for a 3, a 4-speed for a 2, a 3-speed for a 2. And you're kind of seeing where I'm going with this. So what is the deal with that? Why can we do that? And this is only with blower motors, okay? Don't do this with condenser motors. This is a special sort of case with how blower motors function versus condenser motors and how they are wired up out in your condensing unit. Say your motor has 4 speeds. So instead of just a high, medium, and a low, you would have a high, medium, which would be a medium high, a medium low, and a low. Obviously, whichever medium speed you're using, if you're even using a medium speed, you would replace this medium with, even if you're using medium high or medium low, these can both be replaced by medium on a 3-speed motor. You can swap that with, say, if you're going from a 4-wire setup, from a 3-wire to a 4-wire, you could just replace whichever of these with your medium. So that works just fine. These are fractional horsepower motors. It's not going to be that big of a deal in this sort of situation. Okay, so now we know that each one of these speeds, it's okay for you to change it to whatever speed you need. And what you can do is you can just cut off and cap these wires, or if on your boards you have a spot that says something like spare or M1, M2, park. Any of these are dummy terminals. They don't go anywhere. It's just to put your extra speeds you're not using onto a dummy terminal. So it's kind of, it's a neutral to put those wires on there so they don't short out against anything. normal wiring setup, unless you've got kind of an old school one, or I have seen some Goodman, even some newer Goodman, that are using a 3-wire setup, which is usually something condenser motors do, but I am seeing it even recently on new motors. So normally on your capacitor, since this is just a line through, as long as these 2 brown wires, or if you see this dashed one here, if yours is brown and white, it doesn't matter. This can sometimes confuse people. Since it is just a line through for your capacitor, it doesn't matter if you have them like this or if you swap them. And this is only going to be in this case if you have the 2 browns or the brown and white wire going to the capacitor. So this is your normal wiring setup. Now let's talk about if you have a 3-wire setup. With the 3-wire setup, you're going to be looking for something that says line like this one, and then it's going to have something branch off just like this. It might be down here, or it could be up here, maybe come and connect up to the side. And there's even some I've seen, it kind of does a little bracket like this on the side, but this should be your cap, and it would say the same thing here, capacitor, something like that. And all this is saying is that this common wire should be connected to one side of your capacitor, and then your cap, or normally it's a brown wire. With most of them I have seen some that are purple, is going to go on that other leg. Now, the difference between this and the 2 brown wires is that, as we know, this is going to be one leg of power. And again, remember, the common must be on the correct one. So when you're looking at this, where one of those brown wires has that brown and white stripe on it, that's the same thing as this wire. And this is why we don't put this with the brown and white stripe motor. So in this application, it would definitely make a difference. You would short the motor if you put one leg, say on a universal motor. If you put the brown and white with the white, it would burn the motor out. So you need to make sure you have that solid brown on one side and the white on the other. Now, that's just if you're using a universal motor, in which you can do that. Since we know that this common is one leg of your 120, you're going to have a jumper wire here with that common wire. And I've seen common wires that are purple. I've seen some that are orange, white. Again, make sure you are looking at that wiring diagram. Repeatedly, I'm going to tell you this to make sure that you connect the correct one. So since this is your start winding, this is your power. So that jumper needs to be, and it can be on any one of these because that is on the same leg. Make sure your power wire goes to your common. And it'll just jumper off onto, whether it goes to a relay, if it goes directly to power, somewhere along those lines. Most of the time it goes on a relay. It needs to be on your common. So if you do get a universal motor and you do, just reviewing, and you do have one with a white and black stripe, or a white and brown, I should say, you're just going to tie that off, and you're only going to use the solid brown with the common, one on each. As long as the jumper is with the common wire, no matter what color that common wire is, make sure you're only putting that power on the common wire. So what do all these speeds do? Obviously, we know by reading this chart on this motor, the black is high, blue is medium, red is low. Now, since this is a 4-speed motor, obviously we're going to have a medium high, and we're going to have a medium low. Again, if you're switching a 4-speed to a 3-speed, no matter which medium you might be using on your heat or your cool, you can replace that with the medium speed, and it will not harm anything. Now, most units, unless you've got a ream, and I guess there's some other brands too that do it, normally it's going to be a low speed for your heat and a high speed for your cool. Sometimes they'll swap it to where you've got a medium low and a high, or whichever. The point is, when you're connecting this to your heat, you don't really want to put it on high. It's too fast of a speed to be putting that on your heat, and the reason for that is the heat needs to be running slower air over those coils, so it has time to heat those coils and then dissipate the heat into your supply air. So that's why we want to make sure we're at least putting that on a medium low or low. On your high speed cooling, if you're replacing it with a motor that might be newer and it might not have been as strong as a newer motor, there are old school motors that were called shaded pole. You might even have one of those older motors to where it doesn't have a capacitor, and that is what we call a shaded pole motor. So on these newer motors, if it's got too much oomph or torque and you're noticing whistling coming out of your unit, or vibrating sounds, drop it down a speed. So if your high is just blowing too high and it's causing really loud noises, vibrations, whistling, drop it down to a medium speed, so that way it gets rid of that noise. Just a side note, if you do look around in your housing and you don't see a capacitor, one of two things is going on. Either you have a variable speed motor, which has capacitors in the module attached to the motor, or you have, if you're saying, hey, my unit's super old, then that probably means you have a shaded pole motor. So make sure if to check for that capacitor, because, you've been watching videos and they say, oh, check the capacitor. You don't have one, it could be one of these two things. So again, just make sure to check your capacitors. If it doesn't have one, then you're going to need one with the new motor, or you could have a variable speed motor in which you have to change that out exactly the same type of motor. Now, constant torque can be a little different, but we'll get into that later. So, just to review, make sure no matter if you have a 240 volt or a 120 volt motor, always make sure that common, or it'll say line on your motor, needs to be on common. It has to be on there with one of the speeds. You can't just put two speeds together. So obviously it's a little easier with furnaces because your common's going to always be on a neutral line. And on your 240 volts, these are essentially both power. But again, make sure this goes on the correct leg of power on your fan relay board, or the power that's directly connected to it from some sort of relay. Hopefully this has been helpful for you, and of course if you have any questions, just comment below and I will try to respond to them as soon as possible. Thanks so much, guys. Take care and have a wonderful rest of your week.